Hello everyone. Today we are going to discuss about introduction to digital communication. In the previous videos, we have already discussed about analog communication, the corresponding different types of analog modulation techniques that and all we are discussed during previous videos. In this particular video, we are going to discuss the general introduction to digital communication. What is the specific advantages and disadvantages of digital communication, then what are all the types of pulsed modulation techniques are available, that we are going to discuss in this particular video. So this slide representing digital communication system. You know that the communication system will be divided into two different category. One is called analog communication, another one is digital communication. So within this digital communication, the two types of communication available. One is passband communication, another one is baseband communication. So in the passband, we know that ASK, FSK, PSK, so QPSK and so many modulation techniques are available. So that will be coming under passband communication. So another one category is baseband communication. In the baseband communication, different waveform coding techniques are available. The first one we can represent it as pulse code modulation, differential pulse code, delta modulation, and so many types are available in baseband communication. So as per the digital communication system block diagram, the two block diagrams represented here. So the first one representing analog communication system, the second block diagram representing digital communication system. You can compare both the block diagrams, we can identify what is the main difference. So here the first block diagram, the information source, that means your voice signal or your picture signal or your video signal. So that will be called as your information source. That information will be converted as electrical signal by using input transducer. That means whatever may be the physical quantity available in the input side, that will be converted as electrical quantities or electrical signal by using transducer. Then that signal directly applied towards the modulator and amplifier. That analog signal directly transmitted by using channel. So the reverse process also implemented in the receiver side. So what is the major difference between analog communication system and a digital communication system? The few more additional blocks also available both transmitter side and receiver side. So you can see here the source encoder and channel encoder, both the blocks are new in digital communication. That these two blocks are not available in analog communication. Similar manner, the first block is also more important. After input transducer, we are converting analog signal into digital signal. So this analog to digital conversion process is not there in analog communication system. So here the analog to digital converter is the first block after transducer in the digital communication system. Similar manner in the receiver side, digital to analog conversion. So the major difference is the entire blocks after transducer, it will process only the digital signal. So zeros and ones only the input signal. The information completely converted as binary. That binary signal only processed and transmitted. And similar manner we are receiving the binary signal. Finally it will be converted as analog signal by using output transducer. This is the main difference between analog communication system and digital communication system. So here majorly we are going to focus on analog to digital conversion and digital to analog conversion. This particular blocks, how we are performing that analog to digital conversion process. So what is the necessity of digitization? The analog signal itself, we are able to transmit the signal from one point to another point. So why we are moving towards a digital technology or a digital communication system? What is the specific advantages or importance means? So in the pure analog communication side, the signal will be suffered because of distortion, interference, and sometimes including security problem is there in the analog communication. So this particular three major problems are eliminated by using digital communication. So by implementing a regenerator and by using a source encoder and a channel encoder, so and encryption algorithms we are going to use in the digital communication system to improve the security wise. So that's why we are moving towards digital communication. You are digitizing the signal. That means the input signal is analog signal. By using analog to digital converter, we are converting in terms of binary signal. So next, digital transmission. So originally the original signal is analog signal. In the transmitter side, we are converting analog signal into digital signal. Similar manner in the receiver side, the digital signal will be converted as analog signal, because human beings are able to understand only the analog signal. So human beings are not able to understand the digital signal, because in digital communication the information is represented only zeros and ones. By looking that zeros and ones, we are unable to deduct original information. Okay, so that's why the human beings can understand only the physical quantity like sound signal, visual signal, and the corresponding printed information. So the conversion of analog signal into digital pulses is known as a waveform coding. So that we are going to discuss in the next video. So the digital signals may be in the form of binary or discrete level of digital pulses. So here you can see the message signal is available. This message signal, the first process we are converting as a discrete time signal. After converting this discrete time signal into, we are converting as a digital signal in terms of zeros and ones. This corresponding sine wave will be converted as binary signal by performing sampling, quantization, and encoding process. Why digital? What is the specific advantage of converting analog signal into digital signal or digital transmission? Already we are specified the noise domination is more in analog, that will be controlled by using digital. The unwanted electrical noises or other interferences influence the corresponding original information signal. In the main advantage of digital conversion, you can see this corresponding picture, the first signal representing the pulses. So this may be represented as one binary. So this one binary transmitted towards long distance. After distance 2, what happens? Your signal is slightly distorted and also amplitude is slightly reduced. Similar manner, if you are transmitting further, it will be degraded again, the corresponding amplitude wise, and the width of the pulse will be automatically increasing. If you are keep on transmitting the signal towards long distance, what will happen? It will be degraded too much. So then in this particular situation, by using a regenerator, amplifier and regenerator, we are able to regenerate as a original pulse as like transmitted pulse. So because we know that each and every binary represented by using only two voltages, one is +5, another one is 0. So it depends on the line coding technique, we may represent in a different way also. But generally the one is represented by using +5 volt and 0 is represented as -5 volt or 0. So in this particular situation, after amplification and regeneration, we are able to reconstruct as a original signal. This is not possible in analog communication system, because we are unable to differentiate this corresponding changes because of noise or message signal. But here we are familiar, all the information signals are only in binary nature. So that's why we are able to amplify and regenerate your original message signal or binary. That is possible in digital communication system. So here we are represented the list of advantages of digital transmission. The first one, noise immunity, is more in digital communication. Already we are discussed in the previous slide. Because of amplification and regeneration of the pulses is possible in digital communication. Because of that, noise immunity is more in digital communication. The next one is error detection and correction is possible in digital communication. So that is not possible in analog communication. After converting as a binary, we are implementing source encoder and channel encoder. By implementing source encoder, we are indirectly performing the compression operation. In the channel encoder, we are identifying the errors, detecting the errors at the receiver end by using error detection and correction technique. So that is possible in the digital communication. Similar manner, the third point represented multiplexing. So the multiplexing, more than one signal or more than one station signals are multiplexed together and transmitted through single communication channel by implementing time division multiplexing. That is also possible in digital communication. So the fourth point represented, already we are mentioned as signal regeneration. So whatever may be the signals are degraded at the time of transmission because of the obstacles or atmospheric noise or external noise. So your signal will be corrupted. Because of that, signal to noise ratio of the signal will be degraded. That will be enabled or amplified by using amplification and also regeneration. So this is the specific advantage of a digital communication system. As long as we can transmit, even though the long distance, the degradation will be very less in digital communication. So then the data integrity also more in digital communication. Then data security, already we are mentioned. We can implement the encryption and decryption algorithms to increase the security of the communication system. By implementing different spread spectrum techniques is also available. Direct sequence spread spectrum and frequency hopping spread spectrum. That and all, it will improve the security of the communication system. Then implementation of digital technology or IC technology. So what will happen, when we are going to process the digital signal, we can use the digital technology. So that will miniaturize the total transmitter size and also the receiver size or receiver module. Then power consumption is also less in digital communication compared with analog communication. Less cost because mass manufacturing of ICs, the cost of the entire module or transmitter or receiver will reduce by using IC technology. Less weight compared with the analog communication system. Similar manner, here also, even though we have a lot of advantages, the disadvantages is also there in digital communication. The first disadvantage is it requires more bandwidth. So comparing with analog communication, in the digital communication, the bandwidth requirement is more. The second disadvantage, we have to synchronize between transmitter and receiver. So that is another burden in digital communication system. The third one is complexity of the circuit by implementing source encoder, channel encoder and encryptor. So the different hardware requirement, the complexity is more in digital communication compared with analog communication. The quality of the service is slightly degraded compared with analog in this point of view. So the signal to noise ratio and the quality of service is always good in digital communication system. But still, if the degradation is more in the signal strength or in the dispersion of the signal, what will happen? The sudden dip in the quality of the service in the digital communication system. So that is the another disadvantage of digital communication system. Then we know that different types of modulations are available in the communication. So one side we are representing analog communication, another one is digital. So here we are represented as continuous wave modulation, another one is pulsed modulation. In the continuous wave, we know that amplitude modulation, frequency modulation and pace modulation is available. So that we are discussed already. Now in the pulsed modulation, the two different types of pulse modulation techniques are available. One is called analog pulse modulation technique, another one is digital pulse modulation technique. So in the analog pulse modulation technique, there are three different categories available: pulse amplitude modulation, pulse width modulation, and pulse position modulation. These are all the three different types of analog pulse modulation techniques are available. Similar manner in digital pulse modulation technique, the first category is pulse code modulation. Enhancement of pulse code modulation is differential pulse code modulation. Then enhancement of differential pulse code modulation is delta modulation, and so on. So these are all the different types of modulation technique, pulse modulation techniques are available. So in the pulse modulation technique also, as like analog communication system, some parameters of train of pulses. Specifically, what is the main difference between analog and digital pulsed communication means? In the analog communication, as a carrier, we are using sine wave. In the pulsed modulation technique, instead of a sine wave, the pulsed wave act as a carrier signal. So here two different types already we are mentioned. One is called analog pulse modulation. So within that three types available: pulse amplitude modulation, pulse width modulation, and pulse position modulation. So in digital pulse modulation technique, we are mentioned already, pulse code, delta, differential pulse code modulation techniques are available. In analog pulse modulation technique, in which a periodic pulse train is used as a carrier wave. Already we are mentioned, instead of a sine wave, we are going to use a pulsed wave as a carrier signal in the analog pulse modulation technique. Here also the corresponding pulsed wave amplitude is varied, or duration of the pulse is varied, or position of the pulse is varied. Based on that, we are representing as pulse amplitude modulation, pulse width modulation, and pulse position modulation. In the analog pulse modulation, the information is transmitted basically in analog form, but the transmission takes place at discrete level. Okay, the transmission takes place at discrete level, but the information is analog. So here we are represented at the different pulse analog pulse modulation technique: the pulse amplitude modulation, pulse width modulation, and pulse position modulation. The first one representing unmodulated pulsed carrier signal, the second signal representing message signal. So here you can see the sine wave generator or the message signal is applied to pulse amplitude modulator. Another one is square wave. Both signals are applied to pulse amplitude modulator. The resultant output is pulse amplitude modulation. Based on the amplitude of the carrier signal, this will represent the positive cycle, and also followed by the negative cycles are available. The amplitude of the pulse is varied based on the amplitude of the message signal. Similar manner in the pulse width modulation, width of the pulse is varied. During the positive cycle, the width will be more, and a negative cycle, the width will be less. So similar manner in the pulse position modulation, position of the pulse is varied based on the amplitude of the message signal. During the positive cycle, the distance between one pulse to another pulse will be more. Compare with in the negative cycle, the distance between one pulse to another pulse will be definitely less. Okay, so this is pulse position modulation. So the next type already we are mentioned, digital pulse modulation technique. In the digital pulse modulation technique, the message itself represented as a binary form. Okay, so here the information signal is analog. You can see the output is in terms of digital. This digital signal only we are going to transmit to a long distance by using source encoder, channel encoder, and a digital modulation technique. Here we are using sampling, quantization, and encoding process to perform the digitization process. So analog to digital conversion process we are performing here. So thank you for watching this video. So try to share this video towards your friends. If you are interested, you can subscribe this video also. Thank you all.